Welcome to this webinar on topic detection with text mining. I am Rosaria Silipo. I work as a data scientist at KNIME, and I'm here with Vincenzo Tursi. He works also at KNIME as a data scientist. And today we are going to show you a quick implementation for topic detection using the text mining extension of the KNIME Analytics Platform. So let's start then. Okay, so first of all, what is the topic detection? We have a text or a collection of texts, and the topic detection tries to discover the topics that are hidden in the text, and that's important, without any a priori knowledge. Here, for example, there is an example. It's a question for support on the KNIME forum, and if you read it, you can see that the topic of this question is database. It can be described by the word database, of course, but also by SQL, JDBC driver, and maybe a few other words. So a few other keywords describe this particular topic. So is then topic detection the same as topic classification? Well, not really. So both of them look for hidden topics inside a text. But topic detection is unsupervised, while topic classification is supervised. Being unsupervised means that topic detection does not need any labeled data set to work. It clusters keywords together, and then based on these clustered keywords, finds the topics that are most often occurring in the collection of texts. On the opposite, the topic classification uses a labeled data set, transforms the words into numbers, then transforms the text of words into a sequence of numbers, and then once we have a numerical representation of our text, we can train any machine learning model to associate a document vector to a label. Then it becomes a machine learning problem. So those are slightly different. They both look for hidden topics in collection of texts, but one is unsupervised and one is supervised. Okay, so let's go back to the topic detection for now. So how is it implemented? And that's the topic of this webinar. First of all, we need a block for reading and parsing the text. Then, from the reading and parsing of a text, we get a document. A document is a somewhat richer version of the text. In particular, it contains a number of sections. The sections contain a number of paragraphs. The paragraphs contain a number of sentences, and then sentences are parsed into words. So this parsed, hierarchical, organized text becomes a document. Okay, so once we have a document, we have a few operations for text processing. I'm not going to describe them here. We will see them later. And then after we have processed our text, our document, we are going to apply the LDA algorithm for topic detection. LDA means Latent Dirichlet Allocation, and it's an unsupervised technique that finds clusters of keywords to describe topics in the text. Once we have found the topics and we have found the keywords to describe the topics, we can visualize them. Here, for example, there are 3 word clouds describing, representing the keywords that describe 3 topics. So it could be something like that, or it could be something different. Okay, so let's have a look now at the text processing part, because I told you we would talk about that later. So the text processing part includes a number of different operations. We have tagging, we have cleaning, we have stemming, transformation, and there are a few other operations. So those are the basic operations for text processing. Let's start with tagging. When we talk about tagging, we abandon the word, the single word, and we work with terms. Term, like document, was a somewhat enriched version of a text. Word is term is a somewhat enriched version of a word. Somewhat enriched version means contains the original word plus a number of additional tags. What is a tag for a word? A classic tag for a word, for example, is the part of speech. The part of speech tells us if a word is a noun or if it's a verb or an adverb or whatever grammar role it's covering inside the text. Another common tag is the sentiment, if the word is positive or negative or whatever nuance of sentiment are available. Another very common tag is the entity name. For example, if it's a person name or if it's a location name or other names that are available and so on. There are many different tags. You can make your own as well. And you can enrich your word by attaching a tag, an appropriate tag to the word. The second part is the cleaning. Cleaning is obvious, right? So it means that we want to clean the text from supposedly useless words. For example, if numbers are non-interesting for our text, then no numbers, no stop words, no punctuation. If there are words that are tagged as useless words, then no words and things like that. So the cleaning removes things that are supposedly not interesting. Then stemming. If I say promising and if I say promise, those are two different words, but they actually refer to the same concept of promise. So the stemming operation is exactly this operation of removing the grammar inflection from the word and going back to the original root of the word, root which is a stem. Transform, we will not use transform in this webinar, but anyway, so transform operations extract words, frequencies, and keywords from a text. Another common transform operation encodes text into a numerical vector. This representation, we have seen it before, this representation of a text into a numerical vector is useful when we want to apply machine learning algorithms to classify, cluster, or whatever we want to do with the text. This part is actually not needed for the LDA because the LDA algorithm calculates its own keywords and its own frequencies. Okay, so let's talk now about the example that we are going to show today. We are going to use as data set questions from the KNIME forum. Do you know the KNIME forum? That's the link on the for the KNIME forum. The KNIME forum is the place where people ask questions about KNIME usage. We collected these questions in KNIME forum post from the year 2013 to the year 2017. We have around 5,000 questions from 20,000 posts, including comments. And the goal here is to detect the most frequent topics in these questions. So what we want to do, we want to build a workflow to run a topic detection operation on all forum questions. And the hope is to see what the most frequent topics that KNIME users have been inquiring about in the last 5 years on the KNIME forum.
Okay, so how do we identify topics for the questions available on the KNIME forum dataset? We need an algorithm that helps us to identify those topics automatically, starting from a vast amount of information, right? And machine learning researchers have developed probabilistic topic modeling, which are actually algorithms that aim to discover and annotate large archives of documents with thematic information. So in this case, what we do is to analyze the words of the original text to discover the themes that run through them, how those themes are connected to each other, and how they change over time. And The nice thing about probabilistic topic modeling is that they do not require any prior annotations or labeling of the documents. One of those algorithms is the LDA, Latent Dirichlet Allocation, which is a generative probabilistic model, and it's considered an unsupervised algorithm. So what it does, it finds out the top K topics as described by the most relevant N keywords. And it represents documents as random mixture over latent topics, where in this case, each topic is characterized by a distribution over words. There are a bunch of assumptions that are taken from this algorithm. The first one is that LDA is considered a bag of word model. This means that the order of the words in the document it's not taken into account. Another thing that is not considered is the order of the documents. And also the number of topics is assumed known and fixed. It might be that also the same word can belong to multiple topics. And also each document in the total collection of the documents is seen as a mixture of K latent topics. And also each topic as a multinomial distribution over a vocabulary of word. So if we visualize it, the LDA algorithm in a plate notation, we can actually see the dependencies among the many variables that are considered in this algorithm. So first of all, we have the word, which is actually the only variable that is observed in our data set. And then we have a bunch of hidden variables. So if we have a look at the bottom outer plate, those represent the documents, while the inner plate represents the repeated choice of topics and words within a document. In this case, M denotes the number of documents. Instead, N represents the number of words in a document. So the other variables available here are the alpha, which is a parameter of the Dirichlet prior on the per document topic distribution. Then we have the beta parameter of the Dirichlet prior on the per topic word distribution. And then we have the theta, which is the topic distribution for document M, phi, which is the word distribution for topic K, that is the topic for the nth word in the document M. So what we are going to do is basically identify the topics based on the word available in our collection of documents. So I think we can start with a practical example. I can just switch here to KNIME Analytics Platform. Okay, so we will use as example, we will start from this workflow, which already contain some annotations that will help us to basically build the workflow. So first of all, we need to access the data, right? And for this particular example, we will take into account the forum dataset that contain only the titles, which means that we consider only the questions that have been posted in the KNIME forum. So we can have a look at the dataset, and here we have the category of the forum. So some of them will be referring to the KNIME general or KNIME developers reporting, etc. Then we have the URL forum, the topic title, the URL topic, the replies related to each post, the date, and also who posted the question, and also the post content. So we will use this information now to actually create our document type, our document object. And to do that, we need the strings to document node. Okay, I can search for that. and then connect it with a table reader. Okay, for actually here in this workflow, we are going to use the text processing extension available in KNIME Analytics Platform. So if you don't visualize or like if you don't have those nodes in the node repository, you have to install the text processing extension. To do that, you can just go to File and then install KNIME extension and then search for the text processing extension. Okay, the strings to document node can be configured as follows. So if we open the configuration window, we can set the title column, the text, so the full text, which will be used then to basically do the text mining or like the text processing. And then we have several meta information that can be added. So the sources, the categories, the authors, and also the type and date. So let's start by setting, sorry. Okay. Okay. We can start by clicking on the title, selecting the title, which is the topic title in this case. And then the text will be our post content. In the meta information, we can set for the moment the authors, which in this case will be posted by. And then we can set also other meta information. In this case will be the post date. Okay, now everything is set. Another thing that should be taken into account is the tokenization. This allows us basically, this is the model that allows us to set the tokenizer that will be used to tokenize all the text that we have in our data set. So the idea is to identify each single word available in our text. So we will keep it here the default configuration. So we can click OK, and we can execute the node. Okay. So next, we can start with the enrichment process if we want, right? So the idea of the enrichment process is to identify the what are the role of each single word available in our text. So, for example, we might be interested in finding what is the part of speech of each word available in our text, and for this we can use the Stanford node. And if we drag and drop it directly in our workflow editor and connect it with a string to document node, we can inspect here the configuration window. So the general options allows us to identify, so to set. And here we have the tagger options. So there are different models here available. So we can use the English bidirectional or the English left 3 words or the English left 3 words caseless. But if we have a text that has actually other languages, we can set one of those. So French, German, or Spanish. Okay. So for the moment, we are not going to use the tagging, but we will start with the filtering operation. So we can start, for example, by filtering the numbers. And for this, the number filter node is really useful. So we can just connect it with the strings to document and then go into configuration window. And here, as you can see, the filter options are 2. So either we can filter terms representing numbers or also filter terms containing numbers. We are going to use the second option here, which basically allows us to filter the terms that contain at least 1 digit. Okay, so we can execute the node, and then we can use the dictionary filter to actually filter out specific words that we know are available in our text. So I'm going to search for the dictionary filter node. And connect it with a number filter. And then we need actually also a dictionary here, right? So in this case, we have prepared already a table which represents the characters that needs to be filtered from our data set, from our document. So here, if I double click on the table reader, sorry, if I execute the table reader and we inspect the results, those are the characters that will be filtered from our document. Okay, we can close now the output and then connect the table reader with the dictionary filter. Okay, if we go in the configuration window, here we can just select the column containing the strings to filter, which is in this case the characters to filter. And in the preprocessing, we can just replace the column preprocessed document. Okay, now we can execute the node. And we can continue with another filtering node, which in this case is the punctuation erasure. So the punctuation erasure is really useful if you want to filter out the punctuation signs. So I can just drag and drop the node again here in the text preprocessing annotation box, and then connect the dictionary filter node with the punctuation erasure node. Even in this case, we don't have many configuration besides selecting the document column that we want to work on. So I can click OK and then execute the node. What comes next? We can also maybe filter some words that are not meaningful, or like they don't actually add additional information to the semantic of our text, right? So we can use the stop word filter node for this. And then connect it with a punctuation erasure. So in this case, the stop word filter node can use a built-in list. And this built-in list is available in different languages. So English, of course, will be the one that will be used, since our forum is in English, but you can also use it for other languages. For example, Bulgarian or French or German, Italian, etc. If you want to use another stop word list, you can also add it with your dictionary. So you can just uncheck this option, use built-in list, and then select the file that you want to use. Okay, now we can execute the node, and then we can use the converting cases node. It's converter node to actually convert the case of the words that are available in our text. So here the option is to convert the words in lowercase, and we are going to use the same preprocessed document column. And then we can click OK. So the final step of the text preprocessing would be to use a stemming operation. So in this case, we can use the snowball stemmer. I can drop it directly in the workflow editor. Double click on that, and as you can see here, the snowball stemmer has different options, right? So you can use the Porter stemming, which refers to a specific model, or you can use also the snowball stammer for other languages. In this case, we are going to click OK also on the document column, and then we are going to execute the node. Okay, let's go back here. Okay, up until now, if we go in the output, you can see here the preprocessed document. In this case, you are not able actually to visualize all the content that is available in the document object. To do that, there is a really nice node, which is called Document Viewer node. That allows you to actually visualize all the hierarchy, basically, of the document, of the object. So if you visualize the document here, you have the list of all the document title, and the authors, and you can select a specific document, double-click on that, and you will be able to visualize the text for that particular document. So as you can see here, we don't have, maybe this should be for the document viewer, for the preprocessed document. So then we are able to visualize also the steps related to the text processing. And as you can see here, we can also see that we don't have punctuation signs anymore. The words, we have also the stop word filter in this case, that we don't have all the, for example, or and so on and so forth. And we also filtered out the words with the dictionary filter. Okay, so from here, actually, we can now implement the LDA algorithm. So we can search for it. Okay, here it is. So we can just drag and drop it here, and then connect it with the snowball stammer. So as you can see, the topic extractor parallel LDA algorithm allows us to set some parameters. So first of all, the number of topics and the number of words per topics. In this case, we will set 10 topics, and then we want to use 10 words per each topic. And then here we can set the alpha parameter and the beta parameter, which are the parameters used basically for the Dirichlet distribution. So in this case, if we increase the value of alpha, we will make the documents to appear more similar to each other. And at the same time, if we increase the beta, we will make the topics appear more similar to each other. So let's say that in this case, we want to make the documents, or like the topics, appear less similar to each other. So we decrease the value of beta to 0.001, and we will make 1,000 iterations, and we will use 16 as number of threads. This is a parallelized version of the LDA algorithm. So we can click OK and execute the algorithm. Okay, maybe it makes sense to zoom again on the configuration window of the LDA. And here, as you can see, we set the number of topics 10, number of words per topic 10, alpha is set to 0.1, the beta is set to 0.001. Then we have the number of iterations, which is 1,000, and the number of threads, 16. Okay, so probably here there is also another mistake, because we didn't select actually the pre-processed document. So this is something that is really important to do, because we want to actually implement the topic extractor to the pre-processed document. So we need to click OK and then execute the model. Okay, so if you mouse over on the bar here, you can see also the number of iteration. So in this here, we are now to the 600 iteration out of 1000. And once the execution of the topic extractor parallel LDA is computed, we will be able actually to visualize three different outputs. The first output refers to the document collection with the topic assignment and the probability for each document to belong to a certain topic. Then we have the topic models with the terms and their weight per topic in the second output. And the third output contains the table with statistics for each iteration. If we inspect the second output, the topic terms, we can actually see that we have 10 topics that have been extracted. And for each topic, we have 10 words, 10 terms. So each term of each one of the topic that has been extracted has a specific weight. This is basically the score and tell us basically the importance of that specific word in the topic. Okay, now we want to visualize those terms, those words. Yeah, sure. Okay, for time constraints, I'm going to visualize, I'm going to show you the final workflow, which we already have built. And as you can see here, after the topic extractor parallel LDA, we connected the color manager node, which allows us to color each row by the topic ID, right? So then we will use the output of the color manager to inject the results to the TechCloud JavaScript node. And in the TechCloud JavaScript node, we will choose the tech column, the term, as tech column, the term, and we will use the size as size column, the weight. And we can inspect actually the output. And here you can see all the terms that have been extracted with the different colors, which actually represent the different topics. And the size of each term represent actually the most influent topic. Okay, that's all for this workflow.
Okay, so I would like to show you an additional thing. So you have seen from these topics that we have so we have a topic about workflow and KNIME and nodes and execution error. So that's general error in KNIME. We have some topics about molecules and some, I guess, cheminformatics topics. And then we have some problem about variable and strings and loop. That's a bit more advanced, and so on. So we have some topics about programming, some topics about the usage of the KNIME workflow, some topics about connecting to a database, all things like that. Just pay attention to this weight measure, right? So This weight measure is the one that gives you the importance of the topic. Let's try to change for a moment the problem, and instead of talking about questions asked on the KNIME forum, we will talk about the Romeo and Juliet tragedy. Everybody knows the Romeo and Juliet tragedy. So in this workflow, instead of using a table reader, we use a TICA parser node. The TICA parser node is my preferred node because it can read anything. So let me zoom again. Yeah. So, okay. So the TICA parser node can read all these different formats, right? So you can read a Word document, you can read PDF, you can read even CPP, you can read, so all tons of formats are readable via the TICA parser node. In particular, we want to read the EPUB format since the Romeo and Juliet tragedy was downloaded from the Gutenberg project website. Okay, so we use the TICA parser node to read the Romeo and Juliet. We perform the same steps as before, so strings to document to convert the text into a document, dictionary filter to remove some of the words, and so on and so on and so on, until we get to the topic extractor parallel LDA node implementing the Latent Dirichlet Allocation. So let's have a look now at the results. And then you can see that we told the node to get 4 topics, and he found 4 topics, but actually the weight, the reasonable weight is only for topic number 1. So do love die lady D. So that's the whole topic about the Romeo and Juliet tragedy, which is actually love. The other topics, they have been found because we told the node to find them, but the weight associated with each one of these topics is negligible with respect to the main topic. So I just wanted to point out the importance of the weight factor in the results of the LDA algorithm. Okay, so we conclude here this webinar on topic detection. We have now a few questions that people have sent in the past weeks. So we can start now asking some of these questions. Let me stop sharing. Okay, so we can start now with some of these questions. So let me get the question, just a second. Okay, here. The first question is for Vincenzo. It says that the LDA algorithm finds its own keywords to represent the topic. However, sometimes I need to extract the keywords to represent each document. So which nodes do I have in the KNIME text processing extension to extract keywords from a text? And which one shall I use?
Okay, so keywords can be defined as the smallest unit available in the content of a document, right? There are scientific literature propose different kind of algorithms, and those are based on literature, on linguistic approach or machine learning approach, or also statistics approach. KNIME Analytics Platform actually provides the way to implement 3 different algorithms. So one is the chi-square keyword extraction node, one is the keygraph keyword extraction node, and we have also the TF-IDF node that we can use. Actually, for the TF-IDF, we can calculate or extract keywords based on this measure by using 2 different nodes, the TF and the IDF node. Then we can combine them by using the math formula and extract keywords based on this measure. It's kind of hard to say which algorithm to use because it's really dependent on the document that we are, or the collection of documents that we are analyzing. If the documents or the collection of documents that we are analyzing are labeled, then we can use classical measures like F measure or accuracy. In the latest blog post that we published about keyword extraction, we identify basically the or like we choose the algorithm that identified the most common words compared to the other algorithms. So this was the measure that we identified to basically select our algorithm.
Okay. So the next question is still for Vincenzo. And there is a new question that just arrived. Okay. So next question is, what is the difference between lemmatization and stemming?
Okay, so lemmatization is like a, let's say, a crude heuristic approach to chop off like the words that we have in our text, and it's not based on a dictionary. So for some words it might work pretty well, for some others not really. Instead, lemmatization has the same goal as the stemming, but the idea is to return the base of the word based on a dictionary. So let's say that usually it performs pretty well, compared to the stemming approach.
Okay, so the question that just arrived says that the topic do is not really a topic. So what I showed about the Romeo and Juliet, do is a keyword to describe the topic. So there are 5 keywords to describe the same topic, and one was love, one was do, one was die or something like that. So the whole topic is described by the 5 keywords. One of these keywords is do. So it's the tragedy is going, it's a dialogue, right? Because it's a piece of theater. So at the end, a lot of the talking to each other, especially in the Shakespeare form, comes with the do. So it's not that the do is a topic, but it's a part of the frequent keywords used to describe the love topic. So I hope that that was clear. Okay.
Okay. So I have a question for you, Rosaria.
Yeah.
So what is the difference between topic detection and topic classification?
Okay, so I already had a slide on that, but so basically I've already answered, but I wanted to have this question anyway, because I wanted to show a little workflow that implements the topic classification. Okay, so let me share again. Okay, so if we get into the document classification. Okay, so we can see that now when I zoom, the mouse goes a bit wild. So we can see that the steps are more or less the same. So you read the text or the text collection, you perform some enrichment, pre-processing, and then here we come into a partitioning. So we use some of the documents to work as training set and some of the documents to work as test set. And the key node in this particular workflow would be the document vector. The document vector, I already said, performs the numerical translation of a text into a numeric vector. So if we check the input of the document vector, we see that it has a bunch of texts, okay? But if I check the output of the document vector, okay, we can see that instead we have a numerical representation of the same text. Once we have transformed the text into a sequence of numbers, then we can use any kind of machine learning algorithm to perform a classification or a clustering. In this case, it's a document classification, so a classification. And in this case, we perform the classification using a decision tree learner. So that's as I said, the LDA performs an unsupervised topic detection. We can also do a topic classification, but then the transformation required is to transform our text into a sequence of numbers. Okay, so the next question.
Yeah. So yeah, if do I need an ontology when running topic detection?
So I get this question a lot about the ontology. So the ontology is a set of classes which might be related to each other. When we perform the LDA, when we run the LDA algorithm, we get a set of topics, and the topics are described by keywords. It would be nice, not necessary, but it would be nice to assign to each topic a label. So, for example, the topic described by keywords like connect, database, and JDBC probably is the topic can be labeled as database or something like that. So it's if you have an ontology, and if that means if you have a set of classes, and if you want to assign a class to each one of the topics that you have found, then yes, it would be nice to have. It's not necessary, but it's nice. Okay, so the next question. Okay, so here they ask, it's all nice as long as it's English, but how do I find dictionaries in other languages? For example, how can I do a part of speech tagging in, I don't know, Italian?
Okay, so for some of the languages, we already have like a dictionary available, right? So for example, for the part of speech tagging, we have the Stanford Tagger node that allows us to select specific languages besides English. And the same happens with a stop word list. So we can select a bunch of languages even in that case. For other languages, actually, we published a blog post some time ago that might be really useful for this. And I show you now the link to this blog post. And here we are. So this is the blog post that I'm talking about. So it's Chinese meets English, meets Thai, meets German, Italian, Arabic, Farsi, and Russian. So we have a bunch of languages here, and we used different dictionaries. And we found these dictionaries, most of them on GitHub, but also on this Complang website. So you can also go there, go on these links here and check the dictionaries available for other languages.
I think you can leave the sharing for the next question.
Okay. Okay, so the next question is, how can I evaluate the sentiment in a text?
Okay, so there are two possible approaches for sentiment analysis. There is an unsupervised approach that gives a sentiment value to each word. And then there is a supervised approach that uses a label data set. The label data set has been labeled according to the sentiment of the text. So it works the same like before. So we have the unsupervised approach where each word counts, and we need a dictionary to tell us which word is positive and which word is negative. And then we have a supervised approach where we convert the text into a numerical representation, and then we use a machine learning algorithm to learn which words are important, which words define text as positive or negative. Anyway, it's a very complex topic, so probably we will need another webinar to explain how to run the sentiment analysis. But we have, for the ones of you being in London on June 5th, they can also attend the meetup event on text mining, on sentiment analysis especially, and they are going to build their own sentiment analysis application step by step. So if you are in the area of London and you would like to learn how to build a workflow on sentiment analysis, then of course, please stop by. And then we would like to finish with a little gift for you. There is a free download of the book From Words to Wisdom. You can download it from the KNIME Press. You can select ebook and then use the promotion code that is written here. So if something was not clear today, if you need more mathematical explanation, if you would like to implement a sentiment analysis, if you would like to do topic classification, please download the book and use this promotion code to have it for free. So yeah, this was the last question and the last slide. I would like to thank all of you for the I would like to thank all of you for the participation, and I hope to see you at the next webinar. Thank you and bye.
Thank you.